Hello friends. Um, Today I'm going to present you a new lecture, and in this lecture I will be mm, explaining you about differentiation part. Here I will solve two three numericals of class 11 physics. Okay, where an application of differentiation is done. So while solving the numericals, along with the numericals, I will explain you about differentiation. Okay, how it is performed, and also I'll mention some formulas. Okay, so let's begin. So I'll choose a numerical. My first numerical is okay, the displacement. Okay, this is from your chapter motion in a straight line. The numerical is class 11 physics. Displacement x of a particle. So friends, here my question is the displacement x of a particle at a time t along a straight line is given by x equals to alpha minus beta t plus gamma t square. Find the acceleration of the particle. Okay, we are given here displacement. Okay, so you have already you know some formulas. Speed, that is v is equals to, we all know, displacement upon, not speed, it's velocity, it's equals to displacement by time. Okay, and acceleration is velocity by time. Okay, okay, so now what happens here, we can apply at any instant at a particular time t, that is at any instant t we need to find out what is the acceleration of the particle. Okay, so how we can find is by applying differentiation. So now the acceleration that we are going to find, that will be known as your instantaneous acceleration. Why instantaneous? Because the acceleration will be particular for that time t, so this will be known as your instantaneous acceleration. Okay, instantaneous acceleration is always given by v by del x. Okay, sorry, delta v by del t, where your del t tends to 0, or you can directly write as dv by dt. Okay, this is your instantaneous acceleration. Now how we are going to apply this here? You're asking x is given and x is changing with respect to time. The velocity is what? Rate of change of displacement, means displacement with respect to time. So here we are going to find out dx by dt. So what happens here? X is a variable, x is your displacement, t is your another quantity, that is time. See, x is changing with respect to time. So derivation of x with respect to t, okay, that is a differentiation. So here d by dt is your coefficient of differentiation, or you can say differential coefficient. Now what is your dx by dt? You can see here x by t. What is x? X is your displacement. What is t? Time. So dx by dt, displacement by time, is your velocity. So what you will get by dx by dt? We get your velocity. Okay, so d by dt I have written here. Now what is the value of x? Your x is, I'll put the value of x here. X equals to alpha minus beta t plus gamma t square. Okay, now how this thing gets changed? Differentiation. One more thing, differentiation is that when we, suppose this is a long line, we cut it into very small pieces. The smallest piece, this, okay, this process is your differentiation, means breaking into the smallest part, and integration is your just adding up all the pieces. Okay, so here, see, now here what is the differential coefficient? That is d by dt, and everything will change with respect to t. Okay, so to solve this you need to know some formulas. So I'll give the formulas here. So your formulas are differentiation. Okay, let me assume two variables y and x. Okay, y is changing with respect to x, so differentiation will be dy by dx. If y is changing with respect to x, so your differential will be dy by dx. Now here, since x is changing with respect to time, therefore it is d by dt. Okay, in my example here, it will be y with respect to x, so dy by dx. Now formulas, I'll just mention what is, if y is any constant, if y is a constant, what happens? Means d dx of any constant number will always be equals to 0. Differentiation of any constant is always equals to 0. Just remember this. Okay, now again, differentiation is x, coefficient is x, so here must be something x to the power n. If I write here, then your formula will be this power n will come front, n into x to the power n minus 1. For example, if it is d dx of x cube, then it is 3x, 3 minus 1 will be 2, 3x square. Now what if there is something like this, d dx of 2x square? Okay, so here these are the rules actually. Here it will simply follow 2 into d dx of x square. This constant will come ahead. Okay, so it will be 2 into, then differentiation of d dx of x square will be, we will follow this formula. So power is 2, so here 2 will come, and x to the power 2 minus 1, that is 1. So your final answer you are getting is 4x. Okay, this is how you are solving this. One more thing. If there are like this, it is like this, d dx of something like, here it is, x cube plus 2x square. Okay, now your differentiation will be simply algebraic, d dx of x cube plus d dx of 2x square. Okay, so now for this you will apply the same formula. That is d dx of x to the power n is equals to n into x n minus 1 by, oh sorry, it will be d dx of x n. Okay, what is the formula? N x n minus 1. Okay, so using this formula, d dx of x cube will be 3x square, 1 will get reduced from x, 1. Okay, again d dx of 2x square will be, this 2 will come in front, 2 into 2 will become 4, again x power 2, so power will become less by 1, so it will be x to the power 1. Okay, so your answer you're getting is 3x square plus 4x. This is what you get after differentiation. Okay, so These are something simple. Now, okay, so I think it is clear. Now we can solve this question. Here, first we need to find acceleration, right? First we'll find velocity. After velocity, again, if we differentiate velocity, we get acceleration, because acceleration is dv by dt. Okay, your acceleration is dv by dt. So first we need v. We will find v, okay, by differentiating one time. Then again we will differentiate it, we get acceleration. That with this acceleration will be our instantaneous acceleration. Okay, so now this is d dx of alpha minus d dx of, oh sorry, here it is differential our coefficient is t with respect to t na, so I have to put here t, so it will be d dt alpha minus d dt beta t plus d dt of gamma t square. Okay, so now alpha is a constant. Since our coefficient is changing with respect to t, so all other things will become constant. So first term will become reduced to 0, then second your beta will come first, then now dt by dt. Okay, dt by dt. Okay, let me explain you this. Ddx of x. So what happens here? Ddx of x. Okay, this is equal to 1, but how it is 1? Let me show you. So here power is 1, so 1 will come ahead, then x to the power 1 minus 1, you will get 1 into x to the power 0. So anything to the power 0 is always equals to 1. Therefore, okay, ddx of x is 1. Now here dt by beta is constant, so it will come ahead, so it is dt by dt. What is a dt by dt? Again 1, it is 1. Okay, so I'll directly put here 1 plus now gamma dt by t square. Okay, so you can use the same formula ddx of xn. Okay, so guys, this formula, this first formula is very much useful, okay, in your motion in a straight line almost. Okay, this formula will come very handy. So n equals to n into x to the power n minus 1. This formula. Okay, so here what you will get here 2t, right? Okay, so you're getting 0 minus beta plus gamma into 2t. So you get your velocity v is equals to 2 gamma t minus beta. This is your velocity, but this is not our answer, because what we need is acceleration. Okay, okay, also the new page. And so our velocity is 2 gamma t minus beta. So we got our velocity is equals to 2 gamma t minus beta. Okay, now we need acceleration. So acceleration, same acceleration will be your differentiation of, acceleration is a equals to v by t. Change in velocity, rate of change of velocity is acceleration. Okay, that is velocity changing with respect to time, so your differentiation will be dv by dt. So d dt, you'll just put the value of v is equals to 2 gamma t minus beta. So now same, it will follow the algebraic rule, d dt 2 gamma t minus d dt of beta. So here beta is a constant, so we have already seen ddx of a constant equals to 0. Okay, why ddx of constant equal to 0? Okay, let me explain you. It is interesting. interesting one. ddx. Okay, constant. Okay, this is a constant. Suppose I put here 2, any number 2, and here nothing is there. So 2 is always, anything is always multiplied by 1. So in place of 1, if I put here x to the power 0, okay, now these two will come ahead. So ddx of x to the power 0. What happens? X to the power 0. How? We will follow the formula. What was the formula? Formula was ddx of x to the power n is equals to n into x to the power n minus 1. This was the formula. Now using this formula here, 2 into the 0 will come ahead, 0 into, okay, x to the power 0 minus 1. Okay, so this will not make any sense. This will also not make any sense because both these terms are multiplied by 0. So your outcome is always 0. That's why I say ddx of constant is 0. I hope it is clear. Okay, so now here 2 gamma is 2 gamma constant. Second d dt of t minus this d dt of constant term is 0. Just now showed you how it is 0. So dt by dt is again equals to 1. Then in the, okay, so your answer will be 2 gamma. So therefore your instantaneous acceleration is 2 gamma. I hope you have understood this and some differentiation is also clear. Okay, let us take another question where we will understand it a little more. Okay, so my next question will be, okay, I'll take, it is given, so let me write the question. Okay, displacement x of a particle is dependent, okay, they have mentioned dependent on time t, that is displacement x is changing with respect to time t. Okay, on time t, according to relation, they have given you a relation between x and t. According to relation, what is the relation? X equals to 3 minus 5t plus 2t square. Okay, 3 minus 5t plus 2t square. Now if t is measured in seconds and x in meters find its number one velocity at t is equal to 2 seconds. Now they have given you that instant, also particular instant at its velocity you need to find out. And number 2, acceleration at t is equals to 4 seconds. Okay, so we have already got some idea about acceleration is dv by dx, I mean dv by dt, then velocity is your ds by dt, whereas is your displacement, and in this case v is your velocity. Okay, so again displacement is given in terms of t. Okay, this should be given. Now first let us find the velocity. Okay, So here displacement is given, x equals to 3 minus 5t plus 2t square. So velocity, so instantaneous velocity, right? Instantaneous velocity is equals to dv by ds by dt. Okay, here s is given in terms of x, so I'll write here x, that is dx by dt. So what is the value of x in terms of t? So d by dt equal to 3 minus 5t plus 2t square, right? So this is equals to d dt of 3 minus d dt of 5t plus d dt of 2t. Okay, so you can see here this is first term is constant. Okay, this first term, it's a constant, so it will be equal to 0. Then second term minus 5 will come, so it is dt by t. Okay, so here it is 2t square, so plus 2 will come, so it is dt upon it's t square, so this will become 1, so minus 5 into 1 plus 2 into what, it will be t square, right? So here you will use the first formula. What is the first formula? The first formula was d dx of x to the power n is equals to n x to the power n minus 1. So we will use this formula here, so it will give you 2t. 2 minus 1 will be 1, so 1, if you're not writing here 1 also, there will be no problem. So you get dx means v dx by dt is equals to minus 5 plus 4t, but they have given you a time, that is t is equals to, find the velocity when t equals to 2 seconds. Okay, so this part is like this, velocity at t is equal to 2, that is dx by dt at t is equal to 2. So this result, in this result, wherever there is t, you will just put the value of t. Okay, 5 plus 4 into 2. Now what you get? Minus 5, 4 into 2 is 8, so you get 3. Okay, therefore velocity at t is equal to 2 seconds is 3. No? So this is incomplete, it's not 3, it's 3 meter per second. Okay, you have to complete it like this. Okay, now next part we are going to, I hope this part is clear to you. First they have given you displacement, then we found out velocity we know it is displacement by time, so derivation will be dx by dt, since displacement is changing with respect to time t, that is x is dependent on time t. Okay, okay, after differentiation we get this, then we put them, because since they have asked you the velocity at t equal to 2 seconds, so we put the value of t equals to 2 and we got an answer 3 meter per second. Okay, now let us solve the next part. Okay, x 3 minus 5t plus, okay, what is the velocity? Minus 5 plus 4t. So velocity is minus 5 plus 4t. So we need to find out the acceleration. So what is the acceleration? It is velocity by time. So according to differentiation, it will be instantaneous acceleration will be dv by dt. So if you differentiate it, now you can directly say the answer, right? It will be minus 5. Okay, d dt of minus 5 plus 4t. So this is a constant, so it will become 0. Again, this is 4t. So you get here directly 4 because dt by dt is 1. Okay, so your answer is 4. So acceleration is 4. Okay, now they have asked you at t is equal to 4 seconds, acceleration at t equals to 4 seconds. Okay, now do you find any term t here in this instantaneous acceleration? No, no. So your answer will be 4 second meter per second square. Therefore acceleration will be 4 meter. What is the unit? It is 4 meter per second square. Okay. I hope it is clear and some part of differentiation is also clear to you. Okay, let me take another question where you will get some more. Okay, let me write the question. Distance traversed by a particle moving along a straight line is given by x equals to 180t plus 50t square, okay, in meters. Now what they have asked you, find number one, initial velocity of the particle. Okay, you have already learned in class 10 initial velocity is denoted by u, final velocity denoted by v. So initial velocity of the particle and then velocity at the end of okay, when they have asked you to find the initial velocity of the particle, okay, initial velocity means at t is equals to 0, just at the start. At the start time equals to always 0. So when they have given you initial velocity, you should always mind that t is equals to 0 seconds. Now velocity at the end of 4 seconds, at the end of 4 seconds. And number 3, acceleration of the particle. I hope we have already started to solve this. So acceleration of the particle, okay, they haven't given you the time at which instant we need. So your displacement is given, so directly I'll solve. Okay, we by now we have learned the formulas of differentiation. What we have learned? ddx of constant 0, ddx of any number, I mean x is the variable on which something is dependent on x. So here I will write suppose x square. Okay, this is actually this thing. One more, y is a function of x. Okay, suppose y equal to x square. So our differentiation with respect to x means if x changes then y also changes. So differentiation is dy by dx. Now I always put the value of y here, so it will be dx square by dx. Okay, this is what it is. Okay, and we can always differentiate if the differential coefficient, the what is given, it is x, so here must also be some term x, otherwise it will become a constant. So ddx of x and so the formula was n x minus 1. So these are the formulas you have learned till now. Okay, and these are going to be very handy in solving the problems of motion in a straight line, most of the physics problems. And integration is also there. Okay, and I'll do it in my next class, next lecture. So let us solve this. So yeah, first velocity. Okay, let us find velocity. V is equals to, as we have no, dx by dt. So what is your x? I'd like to mention that I haven't written here given and all. Actually I'm giving you the important part which is required, which actually comes, okay, which will be very handy for you so that you get better understanding. Okay, otherwise the whole sum will become a boring one. So d dt of what is the value of x in terms of t, 180 t plus 50 t square. So what you get here? 180 plus this one will be 50 into 2t. Okay, I have used this formula. Yep. So 180 plus 100t. So this is your instantaneous velocity at any instant. Okay, this is the expression for velocity at any instant. Okay, now they have asked you what initial velocity. Number one, initial velocity. Initial velocity. At initial velocity, I have already said you, it is just at the start when time is equal to 0. At initial, time is always equal to 0. So here we will put v t equal to 0. You get 180 plus 100 into 0. So your answer is 180 meter per second. I hope this is clear. Okay, now number 2, velocity at the end of 4 seconds. Okay, you can find it out. Velocity at 4 seconds will be 180 plus 100 into 4, that is 580 meter per second. Now, okay, they have asked you to find out the acceleration of the particle, but they haven't given you any time at which instant. Just find the answer. So acceleration will be, it is dv by dt, right? Change in velocity with respect to time. Okay, that means velocity is dependent on time. In this case, velocity is a function of time. Here displacement is a function of time. Okay, so here if you differentiate it, so this term is constant one, so it will be equal to 0 and get 100. Okay, so your answer is 100 meter per second square. So it was a simple one and I hope it is clear to you. Okay, so again I would like to tell you, differentiation is just breaking up of breaking a thing into the smallest part possible. Okay, whereas integration is summation of small particles into a big one. So friends, I'd like to stop here. Okay, I hope these 3 questions will give you some idea about differentiation and how it is related to physics, and these are the 2 important, okay, formulas of differentiation. In there are more. Okay, so in my next class I will probably bring some more. I'll come with some more questions of physics and solve you and give you some more idea about differentiation. Also, I'll try to put some questions related to integration, okay, and logarithm also. Anyways, thank you very much for watching and kindly share and subscribe. Okay, thank you. Have a nice day.